So in this video, we're going to start CC8, which is the acids topic, and it comes up on paper 1 only. Your definition for an acid is as follows. They are substances that produce H+ ions when they dissolve in solution. So to illustrate that, we're just going to have a look at an example. So I'm going to draw hydrogen chloride, which is HCl. And HCl is a gas at room temperature, so I'm going to give it the state symbol G, and as I said, it is called hydrogen chloride. And you can see from the formula that you've got one hydrogen and one chlorine. Hydrogen's a non-metal, chlorine's a non-metal, so the bond that exists between them is a covalent bond. Okay, it's just one hydrogen bonded to one chlorine. That's hydrogen chloride. If you take hydrogen chloride and you dissolve it in water, so I'm going to draw a beaker, and in my beaker I'm going to put some water, and if I take my hydrogen chloride and I dissolve it in water, what will happen is that covalent bond between hydrogen and chlorine will break. Both of the electrons in this covalent bond will stay with chlorine, and chlorine ends up with a Cl- charge, and hydrogen then ends up with a positive charge. So what's happened is you've taken hydrogen chloride, you've dissolved it in water, the covalent bond is broken, and you end up with Cl- and H+. If we look back to our definition of what an acid is, it's a substance that produces H+ ions when they dissolve in solution, which is exactly what has happened here. When HCl is a gas, we call it hydrogen chloride, but when HCl is dissolved in water, so I'm going to use the state symbol AQ, we don't call it hydrogen chloride anymore, we call it hydrochloric acid, because when it's dissolved in water, it is an acid. Okay, it's not correct to call it an acid when it's a gas. It's only when it's dissolved that we call it an acid, because it's only when it's dissolved that we have these H+ ions. Okay, it's not just HCl that does this. If you had hydrogen bromide, and you dissolved hydrogen bromide in water, you would also get the exact same thing happening. You dissolve it in water, that covalent bond between hydrogen and bromine would break, and you would get H+ ions, and you would get Br- ions. And instead of calling it hydrogen bromide, when we dissolve it in water, I would start to call it hydrobromic acid. So any substance that dissolves in water and splits up to give you H+ ions can be defined as an acid. And I've got a list here of the common acids. So hydrochloric acid we've just looked at, the formula is HCl. Sulfuric acid, that's another one you need to know, H2SO4, and then nitric acid is HNO3. You can see that next to the formula I've got AQ every time, because the acid has to be dissolved in water to be an acid. So your acids will always have the state symbol AQ. So that's acids, they produce H+ ions. We're now going to have a look at alkalis. I'm just going to do this from my booklet. So alkalis, I've got a similar definition here. They're substances that produce OH- ions when they dissolve in solution. So acids, H+ when they dissolve in solution, alkalis, OH- ions when they dissolve in solution. And I'm just going to use the diagram that I've got drawn here. It's much easier than for me to draw it out. So sodium hydroxide is a typical example of an alkali, and sodium hydroxide is a solid at room temperature. It's an ionic solid, so you will see that you've got oppositely charged ions, and they are arranged into a giant ionic lattice. So it's a solid at room temperature. It's a white solid. But if you take sodium hydroxide and you dissolve it in water, what will happen is the Na+ and the OH- ions will separate, and you end up with OH- ions by themselves. Okay, so if we look back at our definition, a substance that produces OH- when they dissolve in solution, if you dissolve sodium hydroxide, you end up with free OH minus ions. Therefore, sodium hydroxide is an alkali. It's not just sodium hydroxide. You've also got potassium hydroxide, okay? And again, because you dissolve them in solution in order to make them alkalis, they have got the state symbol AQ. So acids and alkalis will both always have the state symbol AQ. So if we come back here, we've seen that the ion produced from an acid is H+, and we've seen that the ion produced from an alkali is OH-. So what would happen if we reacted an acid and an alkali together? Well, the H+ ion would react with the OH- ion. And when they react, you are going to form H2O. Because when they react, you're going to end up with 2 hydrogens, H2, and 1 oxygen, O. And you've got a positive charge and a negative charge, so those 2 charges will cancel each other out, and you're just left with neutral H2O. So this here, what I've just written, is called an ionic equation, because I've taken the ion from the acid and the ion from the alkali and I've reacted them together. So it's an ionic equation to show what happens when an acid and an alkali react. We'll just have a look at some typical examples of questions. Describe the difference between an acidic and an alkaline solution, okay? Don't overthink this, just keep it really simple. If they're talking about acids, they want to know H+ ions, and alkalis OH- ions. So that's all you would need to say to describe the difference. Describe in terms of ions what happens when an acid reacts with an alkali. So if they want to know about the ions in an acid and an alkali, then you're just going to talk about the H+ ions in the acid, the OH- ions in the alkalis, and as we've just seen, when H+ reacts with OH-, you form H2O. They can ask you that same question, but just to ask you to write an ionic equation. It's what we just looked at before. When an acid and an alkali react, this is your ionic equation, and you get 3 marks for being able to write that. H+ plus OH- goes to H2O. So the next thing we're going to look at is just how you can identify whether a substance is an acid or an alkali. And for this we use what we call the pH scale. So it is a scale that runs from 0 to 14. If a substance has a pH of less than 7, then it is an acid. If it has a pH of more than 7, then it is an alkali. If it has a pH of exactly 7, then it is what we call neutral. So it's a scale running from 0 to 14 that allows us to identify if something is an acid or if something is an alkali. How, though, do we find the pH of a solution? Well, there are 2 main things that you can do. One is you can use what is called a pH probe, which is kind of a little stick, really, that you insert into your solution, and you'll get a little digital reading and it will tell you what the pH is. Okay, much like you put a thermometer into a solution and you read off what the temperature is, a pH meter or pH probe will do something similar. You just insert it into your solution and it will tell you the pH. So you have your solution, because remember your acids or alkalis are always dissolved in water, so they're never going to be solids, they're always going to be in solution. So you'll take that, you'll insert your what we call a pH probe, which will have a little digital reading at the top, and it will just tell you what the pH is. Again, if it's less than 7, it's an acid. More than 7, it's an alkali. The other thing you can use is an indicator. And indicators are substances that change colour depending on the pH. And your common example, which obviously my diagram's not in colours, this isn't particularly useful, but your common example is universal indicator. And universal indicator turns a range of different colours depending on the pH. What you're not going to see from my black and white diagram is that if it's an alkali, universal indicator will turn blue. If it's an acid, your universal indicator will turn red, and if it's neutral, your universal indicator will be green. So if you're here, bang on 7, universal indicator will be green, and then it gets turns blue as it becomes an alkali, and actually the whole way up here at 14 it's actually quite a dark purple. And then here, again, it's green, As you move towards the acidic side, it turns orange, and then you get a really deep red if it's got a low pH of around about 1. Okay, universal indicator is not our only indicator. There are a number of other indicators. Okay, there's litmus paper, methyl orange, universal, as I said, and this one is called phenolphthalein. You are expected to know these 4 indicators. You need to know their color in an acid, which you can see for the most part. Most of them will be red in an acid, apart from phenolphthalein, which is colourless, and you also need to know their colour in an alkali, okay? And then again, your other option for getting the pH is just using a pH meter. If we look at some examples, okay, so this one here, sodium hydroxide turns universal indicator purple. Which ion is responsible? So don't be put off by this question, okay? If you're being asked a question about acids and alkalis and they're talking about ions, your answer is going to be H plus or OH minus because they are the ions involved. You just need to figure out which one. So sodium hydroxide turns universal indicator purple. So if I go up to my universal indicator, I will see that it is purple in an alkali. So what the question is really asking me is, what ion do you have present in an alkali? And the answer to that will be OH minus. The next question: what colour change would you expect to see when HCl is added to a solution of NaOH in the presence of phenolphthalein? So you're starting off with NaOH with phenolphthalein indicator, and then you're adding HCl. So if I'm starting off with NaOH in phenolphthalein, NaOH is an alkali. In phenolphthalein, I would expect it to be pink. As I add my acid, however, I would expect that pink to change to colourless. So it starts off as pink because you've got an alkali in there, but as you add more and more and more acid, eventually it would turn colourless. So that would be my colour change. Start off as pink and then it turns colourless. Okay, I've got some practice questions here. They're all really, really short. So press pause, have a go, and then press play when you're ready to see the answers. Okay, so I've all the answers written up here, so you can just go through them. H plus, the first one, there are your 3 names of acids. Always going to be AQ. So then when I'm writing my my formula of the acids with the state symbol, it's going to be AQ after each of them. OH minus for an alkali. They're your common alkalis. Again, always going to be AQ. Because it's always AQ, when I'm writing the formula, I can put the AQ afterwards. The difference between an acidic and an alkaline solution, we saw this in the worked examples. Acidic solution has H plus ions, an alkaline solution has OH minus ion. As long as you're mentioning the H plus for the acid and the OH minus for the alkali, you'll get the marks. There's your Ionic equation. Acids less than 7, neutral 7, alkali more than 7. To measure the pH, you can use an indicator or a pH meter. You can also call that a pH probe. These are colours that you'll just have to learn. Universal indicator is red. In an acid, it's blue or purple. You'll get the mark for either. In an alkali, and it's green in neutral. If universal indicator is turning purple, then that means you've got an alkali, so the ion is going to be OH minus. If universal indicator is turning red, then that means you've got an acid, so the ion is going to be H plus. Nitric acid turns universal indicator red. Which ion is responsible? Again, it's an acid. If you're asked about the ion from an acid, the answer is always going to be H plus. In the next video, we are going to have a closer look at pH. We're going to look at how the concentration of H plus ions directly relates to the pH of an acid, and we're going to look at strong acids, weak acids, and then the difference between concentrated and dilute. So we'll go through all of that in the next video.